Good evening. My name is David Morabi. Today I'll be doing presentation for vulnerability scanning for AI tools and techniques. This is a presentation for KAISO. AI systems are transforming industries based on unique security challenges. This presentation will explore how AI vulnerability scanning enhances resilience, trust, and compliance. You will be aware that our traditional way of doing vulnerability scanning, or the tools that we have, or the old techniques that we've been using, they have their weaknesses. You will remember that we do the we do patching. If you manage to patch your systems, your networks, your hardwares, most of the time your vulnerability scanning systems, they will tell you that the systems are fine, but is the data correct? What if the system that you have, it was not fed the right data, or the model to start with was wrong, it has vulnerability itself, or the threat was embedded in this system while it was being built, and the applications like VirusTotal and other security repository databases will not be able to identify that. Is your application secure? No, because remember, traditionally when we do fuzzing, we embed data within the system. We do within the system. Is your system able to read the 0-day, things like that? So hence why we look into vulnerability assessment in AI techniques. Defining vulnerability management. Vulnerability management is a continuous process of identifying, assessing, prioritizing, and mitigating security weakness. In AI, this includes, now we go further, this includes securing the model, data sets, the data that you feed the application, the algorithm itself, the pipelines that you have. We go a bit deeper when we do AI security. We go a bit deeper, we look into that. We don't just go and check if the application was up to date or not. We try to look for more. Is the data itself correct? We traditionally we identify weaknesses in hardware and network when we do vulnerability assessment. But in AI specific application, we include scanning of the model, training data. Training data is the data that we use to feed the AI after you develop the application, to make sure that when you tell the application this is true, this is false, you give it the data. It needs to learn the data that it learns with. So that data, you need to verify if there are no threats in it. Is it the clean data, or there's a embedded data inside there, which is a security threat? And then in reference, APIs and ML ops pipelines. One of the attacks includes adversarial attacks, model invasion, and data poisoning. Purpose of vulnerability scanning in AI is to protect AI systems from the adversarial threats, and data poisoning is to ensure compliance with ISO 27701, GDPR, EU Act, ISO 42001 of 2023. It also is to strengthen resilience and stakeholder trust. Standard vulnerability scanning and scanning process. Traditionally, as you know, when you conduct a vulnerability assessment, the first step is to identify is to discover your asset, is to know the asset that you will be looking into. Then you identify the vulnerabilities in those assets. Then you do risk classification based on the vulnerability that you have identified. You categorize them based on the impact of on their impact to the organization, and then you generate a report, which will be you generate the report based on that, and then you do the remediation. But for AI, you need to first to identify AI assets within the organization. Then you need to detect the algorithmic risk, and then you need to prioritize the vulnerabilities. Then you do documentation. In your documentation, you do technical and compliance risk. The technical is where you look at the technical side where you look in the system itself, the vulnerabilities that were discovered. But now the compliance one is the risk relating to compliance with acts, standards, regulations, to make sure that your organization comply with that. And then from there, you will retrain, you will do the remediation where you retrain the model and update the data. Issues with traditional scanning, it has limited scope for AI specific, because it's only more into, is this there or not there? Is the system up to date or not up to date? Is the firewall there? Is it configured or not? And then we have the dynamic vulnerability. It means dynamic vulnerabilities in models. It lacks integration with ML ops. It produces APAC reports with pure interpretability, whereby there's no clarity, or you need to dig deeper to try to understand the report itself that was being produced in terms of the vulnerabilities that we identified. The issues with existing techniques, we continue to look at it. There's a over reliance on signature-based detection, but AI, it becomes a problem, because we don't only work with that, we work with a lot. And then there's a lack of adversarial testing. There's a weak data validation and integrity checks. There's a fragmented tool ecosystem. One tool cannot provide you with a proper testing. You need to use different applications in order to achieve the testing itself. How AI-based scanning secures infrastructure. It helps to detect emerging threats and zero-day vulnerabilities. It detects the models and pipelines. It enables continuous monitoring. It supports the ISO 2700, GDPR, and AI Act, and it reduces human error. We need to understand that in general, AI-based systems, they need data. They are a bit different from the traditional systems because for email security, the traditional system, it normally misses, for example, I will give you an example with email security. With email security, the what do you call the phishing attacks is an email data content, is a data that's normally needs human intervention to see if the system or the data in the email, is it true, is it a spam or not. But so you collect several of those emails and then you feed them to the AI system, and so that it can start learning them. The moment it learns that kind of emails, slowly but surely, it will start classifying that as a security threat. And slowly, it will continue requesting for human intervention until it is able to pick that and then classify and save them somewhere else so that you continue checking. At the beginning, you have so many emails that are being blocked, but slowly but surely, with time, they reduces as the model learns about that. Compliance and governance frameworks. You need to comply on ISO 2700 security management, NIST AI RMF, which is AI risk management, and then you need to comply on AI Act, EU AI Act of 2024, which is a legal obligation that organization needs to comply to when they are dealing with EU-related organization, and then you or data, and then you need to deal with ISO 27 ISO 42001 Act of 2023, which is responsible for AI governance, which provides guidance and how you need to comply with that. ISO 42001, role of ISO 42001 in AI security is to identifies and assesses AI specific risk. It helps to implement lifecycle controls. It maintains documentation and audit trails and promotes ethical governance and transparency. In conclusion, AI security requires continuous adaptive vulnerability management. Traditional scanners must evolve to address model-based threats, and ISO 42001 ensures responsible, secure innovation. Thank you so much.